Hello everyone and welcome to one more video of set theory, and this is again about the numerical solutions, some of the numerical solutions in the set theory. So let us see this particular example right here. In a survey of 600 students, so I have been given that there are 600 students in total in a school. 150 are found to be liking tea, 225 taking coffee, and 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. So let's solve this particular problem. First of all, how many total students are there, or number of students in universal set? They are given like 600. There are 600 students in total, and I'm saying 150 students were found to be liking tea or taking tea. So I'll represent the students taking tea by number of students taking tea, and that is exactly 150. Then a number of students taking coffee, I'm representing it by number of students taking coffee, and they can be given by 225, while there are 100 students who are taking both tea and coffee. So when I say both tea and coffee, so tea and coffee, and there are 100 students of such kind. So that's the given information with me. I have this information given in the question, and what exactly I have to found? The students who are neither taking tea nor taking coffee. So fundamentally I have to find, like, if I see, then T union C actually represents that the students are either taking tea or coffee, either or, and I want to find its complement. That means neither nor. So that is given that this is exactly, this is what I want to find, that how many students are in this particular complement. So in order to solve that, I can easily see that if out of a universal set I subtract a number of people are taking either tea or coffee, then I'm going to get my answer. And it's pretty simple also, because if I see this entire Venn diagram, and let me draw a Venn diagram for better understanding. These are the students taking tea, these are the students taking coffee. This shaded portion is the portion which is the student. So this is tea, this is coffee, and this entire shaded portion is representing the students taking tea or coffee, and this dotted portion outside is going to represent the number of students which are neither taking tea nor taking coffee. This shaded portion here, this entire shaded portion is representing actually T union C. That means taking tea or coffee. And this is a universal set which has 600 students. So out of this entire rectangle, which value is 600, actually this value is 600. If I find the shaded portion subtracted, I'm going to get the remaining part, which is going to be my answer. So I'm going to use once again the property of union. Number of students taking tea or coffee can be given by number of students are taking tea plus number of students are taking coffee minus number of students are taking either tea and coffee, and that is simply going to be, 150. So it is going to be 150 number of students taking tea. From here, number of students taking coffee minus number of students are taking tea and coffee, and that gives me a number called 275. So I have got the value of T union C. Now the things are pretty simple. I want to find out number of elements in T union C complement, and that is going to be number in the universal set. I'm writing it once again, minus number in T union C, and that is simply going to be 600 minus 275, and you can see that the answer is 325. So there are 325 students, such students are there who are neither taking tea nor taking coffee. Let's see another example. In a group of 100 students, know Hindi, you know, in a group of 100 students, I am not sure whether the question is correct or not. So how many students actually are knowing Hindi? So there are, I think, 100 students know Hindi. Fair enough. 100 students know Hindi. So I'm going to write something like number of students know Hindi are 100. Then it's been given 50 know English. So number of students knowing English are given by 50. And 25 know both. That means 25 students who know Hindi and English both. Each of the student knows either English or Hindi. So that means, and there they are the total number of students. How many students are there in the group? So fundamentally, I simply need to find out that how many students are in the group which either speak English or speak Hindi. We've done similar kind of questions before, so I'm moving a little quick. Number of students know Hindi, plus number of students know English, minus the number of students actually who know Hindi and English both. Hindi and English both. And I hope the results are pretty simple now. It is 100 plus 50 minus 25. And that's give you a very simple number of 125 students are there total. Let's see a little more complicated problem. In a group survey of 60 people, so there are total 60 people are there in a survey of 60 people. So number of people in the universal set are 60. So that is what I'm going to write. Let me write it a little better. Okay, here we go. And it says it was found that 25 people read newspaper H. So the number of people reading H newspaper are 25. Then it says 26 read newspaper T. So newspaper T is read by 26 people. 26 people read newspaper I. So I is read by 26 people. 9 read both H and I. So number of people are reading H and I are 9. 11 read both H and T. So number of people reading H and T are 11. And 3 read all 3 newspapers, right? Okay, number of people 8 read both T and I. So number of people who are reading T and I are 8. And there are, how many people? 3 are there who read all the newspaper. So Hindi, sorry, H, T, and I. And there are 3 people of such kind. So my first question here is the number of people who read at least one of the newspaper, and at least means number of people who either read H or read T or read I. So we have already discussed in the previous lectures that this can be given by number of people reading H, number of people reading I, number of people reading T, minus number of people reading H and I, minus number of people reading H and T, minus number of people reading T and I, plus number of people reading H, T, and I. So I'm going to simply substitute the values here. It's going to be 25 plus 26 plus 26 minus 9 minus 11 minus 8 plus 3, and that gives you a very simple result of 52. So there are 52 people who read at least one of the newspaper. Now let us understand the second part, and I would prefer to solve it by using a Venn diagram. It says that the number of people who read exactly one newspaper. So what I'm going to do is I will be drawing a Venn diagram here. So let me find some space for a second. Okay, I'll try to draw it here. Try to utilize the space at my best. So I have people reading H, I have people reading T, and I have people reading I. Okay, it's not going to serve the purpose. I need a little bigger space. Let me clean this thing up. And so I hope you have gone through this particular problem. So what I'll do is I'll create some space here. Let me clean this entire thing up. And I'm going to solve the second part now. The first part you can pause. You can see exactly the first part of the problem is solved. So I'm going to do the second problem, and once you draw the Venn diagrams, then it becomes really easy to solve these kind of problems. So let me solve it now. So this is the second part which I'm solving. Let me draw a bigger Venn diagram. And I have got people reading H, people reading T, and people reading I. And something like this is happening. This is H, this is T, let's say, and this is I. So first thing first, let us see how many people are in H and T, let's say. So H and T is this portion right here. Let me change the color of the pen. So if you see, there are in total H and T, there are 11 people, but this 11 also counts these three people in here. So H and T is basically 8 people. That means 11 minus 3. How many are in H and I? Total 9 people, and it also counts these 3 common. So in H and I, it will be 9 minus 3. So this common portion is going to have 6 people, 9 minus 3. And when I say how many people are there in T and I, that means reading T and I. So if I see T and I, there are 8 people, and I'm going to subtract 3 because it is this 3 is right here. So 8 minus 3, that becomes 5, and there are 3 people who are reading all 3. So I'll use this Venn simple diagram to solve all the things. So I want to understand how many total people who are reading exactly one newspaper. So number of people reading newspaper H are given 25. This 25 includes all of these also. That means this 25 includes who are reading H and I. This 25 includes who are reading H and T, and also H, T, and I. So I'm going to subtract from this 25 these common people. So how many are H? 8 plus 3 plus 6. So it is going to be 8 plus 3 plus 6. 8 plus 3 plus 6. And that gives you a result 8. Same way, number of people who are reading only T. So number of people reading only T, that is given already 26. That includes all. Minus there are certain things which are common in T, 8, 3, and 5. So it will be 8 plus 3 plus 5. So that gives you a value 10. The number of people reading I. So how many total are reading I? It's 26 inclusive of all. So it will be subtracted by number of people in I, 6, 3, and 5. So it will be 6 plus 3 plus 5. And that gives you a number 12. Now if I total this, that means number of people reading only H, reading only T, and reading only I. That comes out to be 10 plus 8 plus 12, 30. That means 30 people are there